that we discussed related to Node. We talked about that a little bit last week, right? Talked about Node.js at least a little bit.
We mentioned that we were covered.
But so I talked about it at least a little bit. The idea of that it's asynchronous communication, it kind of does things differently. I think I probably mentioned something about how threads are actually not as good as we thought. Something along those lines. Does that sound somewhat familiar to somebody? Old Alex? I'm not getting a whole lot of feedback from the side of the room. We talked about it a little bit. I'll see. I'm getting the feedback from her now. I will reply to your email, by the way. Okay. So in any case, let me just jump in here. We're going to be using this tool called Nitrous. So I'll introduce that today first. That'll be an easy way for all of us to have kind of a something set up. So I'm going to go to nitrous.io. So a website's called nitrous.io. And when you create an account, I'm actually going to pick a different account. CUWCS1. This is actually a very good way to, you know, those places that give you like something for free? Like this particular place, Nitrous, they give you a virtual machine, one per account for free. Then you have to pay for additional ones. But if you have a web host that has your ability to give you like one email address or something like that, you can set that email address to be a catch-all. So for instance, you know, I have several AwesomeFat addresses, but like my main address is Mike at AwesomeFat. But I have that set up to be a catch-all. So if you send any email to anything at awesomefat.com and it doesn't exist, it just comes to my inbox. So you can just make up email addresses to your heart's content. So this will be CUWCS, actually it's called the CUW node. Okay, so somebody, that's our username for this, CUW node. All right, CUW node. Yeah, thank you. CUW node. This is probably against our acceptable use policy, but we're doing this for education purposes, so we don't care. So I'll hit sign up, and this is probably going to send me an email wanting me to confirm that email address. Okay. There it is.
Would you say it's advantageous to make an account here?
Well, you can. It's not going to hurt anything. All right, so I'm going to actually close that. Just go back to this window here. All right, so I'll go ahead and sign in. CUW node. So what Nitrous is, it allows you to run a virtual machine in the cloud. And they have different virtual machines for supporting different languages. We're going to use the one that has Node built into it. So we're going to go ahead and click open after you log in. We're going to click open dashboard. So it's kind of like a way of having a portable development environment always in a web page for some of the server-side stuff. One downside to it is sometimes it's a little bit on the slow side because they're giving you like a portion of their system resources. So when you haven't used it for even like a couple of hours, they shut your server down. So the very next time you come back on, you have to wait for it to boot up. So you get to create your first box for free. This is included in your free trial. You get a free virtual machine for forever, I guess. But you don't get the fastest resources and that kind of stuff, but it's good enough for what we're going to use. So you can make something for, you want to learn Ruby on Rails, Node.js, Python, Django, Go as a Google language, PHP, Meteor. Actually, PHP is pretty handy because one of the reasons we talked about that people are kind of moving away from that model of having kind of PHP. We talked about Ruby on Rails a little bit in here, right? Comparing those different things. So one of the downsides to PHP is that you can't really just start writing PHP code. You have to have some sort of environment set up. So Nitrous is a quick way of just getting you set up to do that. We're going to create ours for Node.js. So we can name this guy whatever. So we'll call this guy CUW CS Node. And we can choose our region. I don't think it really matters. Okay, US East is our option. Okay, so, and you can also link this to a GitHub repo, but repository, so we don't need to worry about that. So I'll say create box, and this is going to like provision our box for us. So the way this thing works, Nitrous, is they have a currency called N2O. Okay, so nitrous oxide, get it? Get your currency. Go ahead.
Question: can you change your box later?
You can delete one and create a new one. Yep. You know, but if you want to have multiple environments and have them live for a long time, that's when you just sign up with multiple email accounts, like I just did. So yeah, officially never do that. Do it. It's totally okay. All right. So we have 10 currency left, which, trust me, that's not enough to buy anything. It's just enough to let you know that there's currency and it exists, and you should buy more from them. Okay, so I'm going to hit next. So, kind of the idea of Nitrous. It comes with an IDE, which we'll use. It's built into the browser, or you can use your own favorite editor and that kind of stuff. So I'm going to say, okay, I read all this crap. Everything's good. So take me to my virtual box. Okay, so notice we have something that looks fairly similar to what we've dealt with in class in here, where we have a terminal down here, so I can type in ls and this kind of stuff. So it's actually, I'm in it's a Linux-based environment, but I'm in a Linux operating system hosted in the cloud. Okay, so this isn't my local file system. This is a file system in a Linux operating system hosted someplace else. All right, that I can actually run my code from. All right, I'm going to bounce back and forth here between this little tutorial. I mentor this class, and so it's kind of good introductory material. So I'll go with this. So in any case, when we type in Node in here, it's going to give us kind of a runtime environment. So if I just come down here, I type Node, it's going to put us at the command prompt. So this is kind of like the interactive Node terminal thing here. I wonder if I can make this part bigger. Oh yeah, there we go. We can see that good? Okay. So we're like in Node mode right now. Haha, get it? Node mode. So now we're talking directly to the Node server. Now, if you remember correctly, let me bounce over here real quick. Oh, the name of our product for the thing was called Coder. C-O-D-R. Coder. Isn't that like the cool, hip, like Tumblr? Coder. I hate you. All right, and so I drew a picture somewhere. It doesn't really matter. So in here we have our, here's Nitrous. And Nitrous is actually hosting Node for us. I should go this route. So Node is a tool that you can download and run on your computer yourself, locally. So it's hosting the Node server for us. We just launched it, so now we have a command prompt. So we're actually talking directly to the server here, as if we are a client. So rather than having a client sitting over here talking over the internet, we're sitting directly on the server talking to the client directly. So this is a JavaScript runtime environment that knows how to execute JavaScript. So we can feed it JavaScript, it'll execute it back to us. Okay. So just the kind of a quick little, we'll fly through this really, really quickly. So this is kind of a JavaScript tutorial, if you will. So I can go in here and just say like, var name is equal to Mike. Okay, and then I can say something like, create a couple other variables. Notice that this guy is a loosely typed language. We don't give it types, we just create the variables. And then I'll write something out to the console, actually. So we'll just say console.log name. Okay, and then it spit out Mike. to the screen. Okay, so just showing us working with this interactive interactive loop here. Okay, so variables, writing stuff out, Booleans. So Boolean expressions exist. Here's a way of defining objects. So I can do something like, actually this is a list. So here's a variable called actors. That's going to be a list of actors. We call this guy, this guy's called a dictionary. So every element of this has a key and a value. So actors.Kyle is going to be Dale Cooper. Actors at bucket Cheryl will be Laura Palmer, so on and so forth. That's a way of working through a dictionary for that. Here's another dictionary, so they're just giving you other examples of dictionaries. Then you have arrays, normal arrays like we're already relatively used to, null values. The default for something not having a value in it is undefined. It's actually a keyword, undefined. Here's your if statements, if else. So we've learned how to create memory, a couple different ways of storing things, ask questions, if stuff, and then repetition, loops. Yeah, you'll notice that loops look pretty similar to Java loops in that they look the same. Okay, it's a C-based language, just happens to be a loosely typed language. Okay, so if we want to write a little loop in here, the syntax for for loops, we create a variable locally. Oh, I keep wanting to switch away from this. So I could do like for var I is equal to 0, I is less than 100, I plus plus, and then you press enter, kick it down a line, opening curly brace. Let's do console.log I, and close, and there's my output. All right, so interactive loop. So Node just runs JavaScript. Okay. In a pinch, if you didn't, so this actually takes it to the next level. If you really wanted to write JavaScript and run it, you could actually just write it directly in a web browser because your web browser knows how to execute JavaScript. But in this case, we're actually doing it from the command line through the web browser, so it makes it a little bit more geeky, I suppose. All right. Functions. Normal function here, you can define it, then notice functions actually get stored inside of variables. So here's a little function called doubler, for example. So I can say var print something. Okay, and this guy is going to take a var something. And this guy will say console.log something. Then we'll close that, although that's actually terribly written code. It's not even legal code, to be honest. Var a function is equal to print something, var something. Then console.log of something. Okay. Oh, no, I need to put my semicolon there. Row. I didn't like it because I didn't put my semicolon all in the same line.
I think you put the extra bar.
Oh, I didn't say function either. All right, we're going to get this right the third time. Var a function is equal to a function that takes in, I think it's var something. Do I have to give it a type? Nope, just takes in value. Takes in something, and this guy will just do console.log something. Close that semicolon. Okay, so now we have something called a function. So I can say a function blah, and it prints out blah. I can say a function 5, prints out 5, so on and so forth. Okay, so this guy just knows how to print something to the screen, write a function, but you actually store functions inside of variables. So in JavaScript, functions are actually what are called first-class objects. So you can pass functions into functions. All right. Scoping rules, just normal variable stuff. Closures, this is an idea of when you have something kind of embedded in something else. So actually this is a decent idea of a enclosure. So we have var outer, which is going to be a function, and this guy would be called a closure. All that stuff is called a closure. It's storing aspects of your function. And then within that, you actually have another closure. So this is a closure with a closure inside of it. Programming thing, not that important for us right now, because what we're going to do with Node is relatively unimportant. Okay. Prototypes, inheritance. So this is your object-oriented stuff. We'll swing back through this stuff when we need it. Okay. But what we want to do is we want to get down to the actual Node stuff here. So we're going to look at the hello server. We want to run a server here. Okay. Okay. Now, so we're going to actually create a file, which the built-in thing gives us some ability to do things. Now, notice we need this thing called the Express module. So Node is a kind of a base tool for executing JavaScript programs. Well, in this case from the command line, but then we can use it for actually running HTTP servers. So we're going to start off with this Express module. So in order to use it, we're going to have a package manager, this Node package manager, npm, Node package manager, and we're going to use it to install Express. So I'll actually go, I think it's just quit. Oh, is it that? No, oh yeah, just got to do that twice. All right, so there's our npm install Express. So this is going to go and find it, download it, and install everything. So while that's cooking and doing that stuff, there it's done. All right, that then gives us the ability to work with this code here. So I'll just go ahead and steal this code, and we'll paste it in here. So first things first, we have our workspace here, and I'm going to go ahead and just create a new file in here. So I'm going to hit this little plus sign, and we'll go ahead and save this. We're going to save this file. We're going to call this hello server.js. Save that. I'll paste this code in here. Okay. So this guy creates an instance of Express. Well, creates a variable called Express, which is an instance of the Express object, the thing we just installed. Okay. Then we create. Well, actually, this makes it available. Then we actually create our instance right here. So we have a variable called app. Notice in JavaScript, none of the variables have types. A var is just a generic container. We can throw whatever we want in there. Okay, and here's where we actually generate our instance of Express. So that's creating an instance of the variable. In Java, this would be equivalent to saying Express app equals new Express. Okay. Now we're creating some entry points. So this is kind of what we talked about a little bit with RESTful APIs, but essentially this guy has this entry point of type get. So we did talk about RESTful APIs, right? In terms of get, put, post, delete for HTTP protocol. Give me some feedback. Somebody? No? All right. So we can think about this idea of an API initially. So an API is an abstract programming interface. This is a tool which handles, well, why don't we say which typically handles requests associated with data. So, for example, the PayPal API might allow you to request a listing of all your transactions. So you would hit the API, you would give it any sort of credentials so it knew you were talking about your account, and then it would give you back a list of your transactions or something like that. Similarly, it could also allow you to, request a payment. So you could put something up there and it would actually create a new transaction, which would then use PayPal to send a request for money to somebody, things like that. So you take the feature set that is PayPal, the API would allow you to plug into that feature set through your own applications rather than going to PayPal's website and doing it. Okay? PayPal's mobile app for your smartphone likely uses, well, I would hope they use, their own API. PayPal's API for communicating with PayPal and doing PayPal-y stuff. All right? So historically, APIs were somewhat proprietary in nature. That is, when you sent a request to the API, you were still communicating over the internet. You were having to establish a communication channel. So you'd still have this type of thing set up. So the API would sit here. Well, let's do it this way. We're going to say Express is actually your web server. All right, so on Nitrous, we're running, which supports Node. We've installed, using the Node package manager, a package called Express, which supports allowing us to run a simple web server. And I say simple, it's deceptively complex given how simple it is to use. And that's what we're going to be talking about over the next couple of classes, is this idea of asynchronous communication. So we've installed Express on Nitrous, which leverages the Node install. So really we have Node on here as well. So this is kind of the development stack. And then what we're doing is we're actually writing an API in terms of Express. Okay, so this API is going to handle incoming requests. Initially, we're only going to support a GET request. All right, but what would happen is you would have clients, this guy. These guys would request information from an API. This could be a web browser. This could be a smartphone. This could be, anything that's internet connected by today's standards. Okay, so this guy would send a request, would open up a socket to this web server and start sending requests to the API. Now, historically, these requests were probably fairly proprietary. So if you wanted to get something from PayPal, let's keep using PayPal as our example here. The old proprietary way might be for you to send something over the client, kind of like what we've done in our server for file transfer stuff, where we've kind of just made up a protocol for sending stuff back and forth. So, over the socket, we might first send yo. And then the server then responds back with sup. All right, and then maybe we send it a number. Yeah, it's fine. This is no longer PayPal, so this doesn't make sense. So this is our gibberish API. So yo comes from us, sup comes back, proving we're talking to each other. Then we send them a 5, and then maybe he stores the 5 in a database somewhere, and then spits back to us stored. Something like that. All right, so that's the communication going back and forth between the client and the server here. And this would be proprietary communication. Okay, each of our little commands here was just a string. Okay, if we needed to say more than one thing, maybe we would say store :5. Okay, and then maybe the response was stored. So right here we kind of gave it our own little proprietary protocol, a proprietary syntax for what do we want you to do? Here's what I want you to do it with. These are the parameters you need. Okay, or maybe we're storing 5 strings. So we'll store cow 5 times. Maybe that's what that means. But in any case, we're inventing our own little protocol. So this would be a proprietary approach. Now,
Hipster API.
this is Hipster API. Okay, brought to you by Nabisco. Okay, so in any case, then we started needing some standards. As we had a whole bunch of different kinds of clients in the early days, most of the clients, when I say whole bunch of different types of clients, most of them were web browsers, talking to a whole bunch of different types of data sources. Not all are web servers, sometimes, or at least not all are things that are serving web pages. Some of them are serving information like cows and stuff like that in this particular case. Okay, this is very realistic stuff. All right, so in any case, then we came out with a standard called Soap. And Soap actually leveraged XML as its standard. So what it did, I mean, it had some standard functions and stuff like that, but among everything else, it really just said, your protocol, the language you're going to be sending back and forth, is a tag-based language like XML. So instead of saying, yo, sup, this stuff, we would probably send something that would look like maybe a com tag, /com, send yo in there. Then you'd have a com sup. Actually, wouldn't have the double quotes around it. All right, so now the client and server are sending a structured communication back and forth, these XML documents. Then we might have a store command. So we're going to say store and what are we going to store? We're going to store, well, we might say quantity 5. That's fine. Let's just do QTY. And value, val. Oops, hello. All right, so the client would send a store request to the server. Server would receive it, looks like this. And then the server would respond back probably with another com. Just communication called stored. Okay, so really Soap gave us the starting point for doing communication in terms of a standardized protocol with functions, standardized functions that they just invented in Soap. Okay, now up until reasonably recently, maybe 2 or 3 years ago, Soap was still the preferred standard for what API calls existed, and XML was still the preferred standard for how you structure your data, your communication. Now we would do everything in JSON, more than likely, instead of XML. So the JSON equivalent of this would be I'll just do one of the lines here. I'll just do this line. We'll do JSON equivalent of that line. So we have a type is store, a qty is 5, and a val is cow. Something like that. So this is a JSON object, and in this JSON object, every object has a type. So this guy's type is store. This guy, because it's store, it can expect then a quantity and expect a value, so it's all stored like this. So this one line and these several lines all kind of mean the same thing. You could split either one of these up into multiple lines, but even if we put all this on one line, you'd have a whole bunch of like less thans and greater thans. It would be kind of complex to look at. This looks a little bit cleaner to us. Okay, so this would be a JSON example. And this would be an XML example. And that's just data representation, how we're actually sending stuff back and forth. Relatively insignificant for these technologies. Just generally speaking, the less words, the better, right? Okay, so in any case, SOAP had really nothing to do with XML in general. In fact, later implementations of SOAP did support XML as well as JSON. The biggest thing that changed wasn't the data representation. So data representation languages are used for making requests and getting responses from between the servers and clients. How do you send information back and forth? Okay, in terms of encoding the information. What's really changed is the difference between SOAP and Restful. Let me do this. So these Restful APIs, okay, these guys, they take, instead of inventing a bunch of functions like SOAP does. So with SOAP, we might say that if you want to upload something, you have an upload function. If you want to download something, you have a download function. They have ways of you developing your functions. Okay? With Restful, they do everything in terms of something called Crud. Okay? Crud stands for create, update, delete. Okay, basically the idea is that all APIs at their simplest, well, really all APIs can be defined in terms of these three functions. How do I create stuff? How do I update stuff? How do I delete stuff? So in your typical SOAP API, you would have functions for create, functions for update, and functions for delete. Makes quite a bit of sense, right? Okay, well, we need to be able to create, update, delete stuff, so SOAP should probably support create, update, delete. But SOAP still had to invent that protocol, and they had to write something that was SOAP compliant so that when you sent a create request, it interpreted it and pulled the information out of it and things like that. Well, with RESTful APIs, they said, you know what? Rather than rely on us having this relatively bug-free implementation of a SOAP server, okay, that is the way SOAP would work if we were sitting here. Actually, look like this. Okay, so a client would make a request using the HTTP protocol. That's the hypertext transport protocol. The way that clients talk to web servers. Web servers speak this language. So this is a standardized protocol, right? HTTP. So the client would make a request over the HTTP protocol using the HTTP protocol. In this case, the server it's talking to is the Express server created by our node dealie here. Okay, it would then send that request onto the Soap implementation that you were using for this server. So Soap being a standard. So there might have been 15 or 20 different Soap implementations out there, but they all followed the same standard-ish. Okay, fair enough. And so in that standard, that's where they would actually implement the API. Okay, so your request was going to this Soap standard here. As opposed to the older way of doing this, if we just move this down a little bit. Actually, let's just get rid of this stuff for right now. The older way of doing this would have looked like this. Client makes requests through HTTP. And then we'll say proprietary. I'll just say propri. Through some program that the developer would write, which then delivered the API. So that means that if this is PayPal's API and they've written this in a proprietary way, you have to go and look up their documentation and find out how to use that tool. It's not a standard. Maybe an analogy might be if I put a telephone in front of you, it doesn't matter which telephone I grabbed off the shelf at Target, you could use it because you know how to use a telephone. The concepts of the public interfaces of a telephone they're standardized, right? You'd expect there to be a handset thing, you'd expect there to be buttons and that kind of crap. Any of us could use that telephone if I put it in front of you, even Brazilian guys. You have telephones, right?
Someplace.
Actually, do telephones even, when was the last time you heard a ringtone? A dial tone. Ringtone, we still hear ringtones. Actually, dial tones become such a foreign word now. When was the last time you heard a dial tone? Does anybody have a I've had this talk before. You still have a landline phone, right? That's it. So you have a landline?
Just at the stores.
Okay, so you got a dial tone. Okay. So, but generally speaking, they don't exist anymore, right? So in any case, the old way of doing this would be we would have this proprietary program that some person at PayPal wrote that we would have to know what our requests needed to look like. So we would have to say, this is the yo. He would respond back with sup. Then we would send stuff back. So it was a proprietary communication protocol. Where with Soap, our requests are dictated by this Soap standard. So if you were talking to 10 different Soap APIs, Soap-based APIs, the requests would always look very similar. You were using the same standardized functions, all right? But you still needed to learn the Soap way of doing things, okay? Now, Restful implements Crud in terms of HTTP functions. That is, get, post, put, and delete. Get means, I left something out of here. This is create, retrieve. I was just going through too quickly in my head. Okay, so get is a retrieve. Post is a create. Put is an update. Delete, guess what that one is? Delete is a delete. All right, so RESTful APIs is just kind of a fancy, complicated way of saying, hey, we're just going to use HTTP's functions, these four guys, because guess what? It happens to support it happens to support four things, and we happen to need four things to do what we need to accomplish with an API. That is, create, retrieve, update, delete. Make sense? So now what we get with the RESTful version of our APIs is you get this look. With soap removed. We don't use smoke. We don't use soap. Very stinky. Nothing. I get nothing. It's killing me, people. All right. So in any case, we've removed even the standard here. Why? Because the standard already existed. In our communication with SOAP, we actually were utilizing two standards. We were doing all requests through the HTTP standard, and then we were doing request processing through SOAP. Well, why not just do both of them with HTTP? Why have two separate products? That makes sense? So I suppose we could write it a second time if we want, but it's only implemented once. So HTTP is being used on this side as well for actually processing the requests. That's what a RESTful API is. It's an API that just leverages this existing thing, HTTP, that's been around forever and ever to handle all requests. Okay, so real quick, in our last minute, just back to the code so we can see it work. So we're setting up a get endpoint. That is, retrieve information. Okay, that's what get does. And the endpoint's going to be on /, so that's just the main local host thing. And then it's taking in a request and a response. So this is HTTP protocol. So we send a request, and we receive a request, and we send a response. We're using that response to send the string hello world back. And then when we tell app to listen, this is our web server, we're saying listen on port 8080. Okay? So I went ahead and I saved that. Okay, now we can try running the code. So we'll go ahead and use Node that's built in. And did I call it hello server? I don't remember what I called it. Doesn't matter. We'll just update it. I called it hello server. No, I just spelled it a little differently. So there's hello server.js. Okay, we'll go ahead and run that, and it's sitting there running. My server's running, just like we started that server when we wrote our Java one. Okay, server's running. A little bit less code for this guy. And finally, the punchline. Okay, so we're going to go to our Nitrous IO box, going to preview port 8080. So that's this guy right up here, preview. There's port 8080, it's built into the thing. And what this is going to do is it's going to launch a web page. So this is kind of Nitrous's way of us running a server there, but viewing it here. So notice it shows my full, that's where my Nitrous server actually lives, that whole thing. On port 8080, there's hello world. Okay, so we just used Node to set up a very simple server that outputs the string hello world when we make a get request on the /URL. Okay, that is that URL. That's the endpoint /. Okay? All right, so we'll come back on Wednesday. We'll continue on doing some a little bit more complex things with Node, but that's the basics of Node. Okay? I'll see everybody then.